Algebra 2, Chapter 9, Section 4, Solving Quadratic Equations by Factoring. When a quadratic equation is simple to convert into factored form, it is easier to solve by factoring. To solve, we use the zero factor principle, which states if you have two things multiplied that equal 0, then either one has to be 0 or the other, or both. So when in factored form, we have a, which is not 0, times x minus r times x minus s equals 0, then r and s are the zeros and therefore the solutions of the equation. So x is r, x is s are the solutions. And this works both ways. If we know the solutions, we can write the equation in factored form. Let's practice. Solve for x, part A. Here it's already in factored form, with one small exception. Remember, factored form has a negative in the form, so a minus here. So the solutions are x is q and x is negative 5. Part B. Here we don't have it in factored form. Let's see if it's easy to put into factored form. So let's convert it into standard form first. So to go to factored form, we would need two things that multiply to negative 21 and add to negative 4, since the coefficient of x squared is 1. Well, 21 and 1 won't work. What about 2 isn't go in 3 and 7? So negative 7 plus 3 is negative 4. Yeah, that does work. So x minus 7, x plus 3 gives us negative 21, negative 4. And now we know the answers. X is, remember, the minus in the form. Negative 3, x is 7 of the solutions. That was much faster than quadratic formula even. Now you could use the quadratic formula and get the same answer, but it would take more time. C. So here we have it already in factored form, almost. We have this strange 2x here, though, which is not part of factored form. So we could take the 2 out, or we can just go ahead and use the zero factor principle to find the answer. 2x minus 4 is 0, or x minus 4 has to be 0. So we can solve each of these equations to get the answer. So 2x is 4, x is 4 halves, or 2. 4 over 2 is 2. X is 4, so x is 2 or 4 of the answers. Part D, we have a similar problem. This time, instead of using it directly, let's factor this 2 out, and we'll end up in factored form. X minus 4 is 20. Oh, oops. We have a bigger problem. There's a 20. This isn't in factored form at all. Because of this 20, we have to multiply this out. X squared minus x minus 4x plus 4 is 20 over 2 is 10. We can go ahead and divide by that 2. So dividing both sides by 2, we get this equals 10. So we have x squared minus 5x, combining the two x's, subtracting 10 minus 6. 4 minus 10 is 6. Is 0. Now this might pop out at you as one we can factor. 5 and 6. Remember, we can do minus. Here we could do minus 6 and 1 to get to minus 5. So we have minus 6, 1. It gives us negative 6 when we multiply, negative 5 when we add. And so x is 6 or x is negative 1 are the answers. So that shows you how we can use factored form to solve very quickly when we can factor. And we can't always factor. Find the horizontal and vertical intercepts of the graph of h of x is 2x squared minus 16x plus 30. Well, the y-intercept is the vertical intercept, and that's just the constant term, so that's easy. The vertical intercept is 30. But the horizontal intercept, or intercepts, where it crosses the x-axis, we need to find when the output is 0 The output is 0 is going to be a quadratic equation in standard form. So if we can factor this, we'll know the zeros. So we're wanting to know when is the output of h 0. And we can go through this relatively complicated factoring, but the first thing to realize is we can divide by 2 everywhere and make this much simpler. Now, what two things multiply to 15 and add to 8? 5 and 3. So negative 5 and negative 3 give us negative 8 and positive 15. So 0 is x, negative 3, and negative 5. And that tells us that our horizontal intercepts are 3 and 5. Because the zeros, remember, it's 3 minus 3 is 0. Find the points where the graphs of f and g intersect, given that f of x is 2x squared minus 4x plus 7, and g of x is x squared plus x plus 1. So to find where two graphs intersect using algebra, we could do it graphically, of course, too, but using algebra, we need to set these two rules equal to each other, the two functions' outputs equal to each other, and solve to find where the outputs are the same. That'll give us the input values where the output values are the same. So subtracting x squared from both sides, we get x squared. Subtracting x from both sides, we get minus 5x. Subtracting 1, plus 6, which is this exact same quadratic we did here, except we have plus instead of minus. So let's see how that affects the answer. 6. Well, it would have to be, if it was 6, it'd have to be negative 6 and negative 1, so that won't work. But we could have negative 2 and negative 3. X minus 3, x minus 2 is 0. So the zeros, the points where the outputs are the same, would be, the input values would be when x is 2 or when x is 3. Now that's not an answer to the question. The answer was find the points, so we need to find the points as an xy pair. We've got two x values. We need to find the corresponding y values. I'll use this function to find them because it looks easier to evaluate, and it doesn't matter which we choose since they're equal at these inputs. So g of 2 would be 2 squared is 4, plus 2 plus 1 is 7. And g of 3 would be 3 squared plus 3 plus 1, which is 9, plus 3 is 12, plus 1 is 13. So the points would be 2, 7, and the x value is 3, the y value is 13. And that is the answer to the question that's being asked. When it asks about points, we need to give points as the answer. Now let's solve these equations by using the quadratic formula. This is a old slide, sorry. This was from 9.3. We don't need to repeat that. We could just go back and look at that video. Write a quadratic equation in T that has the given solutions. So let's start with A. And remember, we have to do a variable in T. So the given solutions would be T minus negative 1 plus 1, T minus 2. Now, is that the only possible answer? No, because we could have any value for A and still have the same zeros. Okay? There's many quadratic equations that have this solution, so we just have to write one of them. Part that was A. Part B, there's a couple ways we could do B. We could just again write T minus 2 plus square root of 3 times T minus 2 minus the square root of 3 equals 0. That's one answer. Another answer would be to realize that if this is true, then T has to equal 2 plus or minus the square root of 3. And we could use this fact to write a quadratic equation quickly because of this plus or minus by subtracting 2 and now squaring both sides. We have a quadratic equation that whose solutions are 2 plus or minus the square root of 3. Either of these is correct, and you can see the second is simpler, but they are the same. You can simplify one to the other. And for C, we just have t minus a, so we just have these abstract zeros. T minus b are abstract solutions. And that's almost it. We have to have an equation equals 0. Let's solve this equation. 2x cubed minus 5x squared is 3x. It's not a quadratic equation, but maybe we can turn it into something that has a quadratic equation in it. Subtract the 3x. Now let's factor this. So the first we could do is remove an x. Now we have 2x squared minus 5x minus 3. Two numbers that multiply to negative 6 and add to negative 5 would be negative 6 and 1. So we could split this into 2x squared minus 6x plus x minus 3 to factor by grouping, which we have to do because of that 2. That would give us 2x in common to this first part, x minus 3, and there's nothing here. But x minus 3 is in common in both, so that gives us 2x plus 1, x minus 3 is 0. Because we can pull the x minus 3's out, we're left with just this 1 to add to the 2x. Now we have three factors multiplied together to make an equation we can use the zero factor principle to solve. So we can solve this, we get zero factor principle, so write three equations, each of them set to 0. X could be 0, 2x plus 1 could be 0, x minus 3 could be 0. We already have an answer here, so 2x could be negative 1, x is negative 1/2, and here x is 3. So we have three solutions. X is 0, x is minus 1/2, x is 3. That's one way to solve this equation. Another way to solve this, which might be easier, would be to recognize that x being 0 is a solution here. So we could write x is 0 as a solution. Now we can also think about maybe there's other solutions that aren't 0. So when x is not 0, we could get rid of that x because we could divide by it, but we can't do that when it is 0. So when x is not 0, we'd be left with this equation, which we could solve by factoring or with the quadratic formula. Maybe that's easier. With the quadratic formula, we'd have negative b plus or minus the square root of b squared minus 4ac over 2a, which gives us 5 plus or minus, and here we have 4 times 2 is 8. 8 times 3 is 24. 24, but we have minus minus, so we add. So 25 plus 24 is 49 over 4. 49 is a perfect square. It's 7 squared, so we could write this as 5 plus or minus 7 over 4. So x would be 5 plus 7 over 4, which is 12/4, which is 3. Or it would be 5 minus 7 over 4, which is minus 2/4, which is minus 1/2. And now we have our three answers. X is 3, negative 1/2 is 0. And the same answer. So there's another way of doing the same problem. Solve y to the 4th minus 10y squared plus 9 equals 0. This isn't quadratic either. Here we can introduce a concept called substitution. And this is a very useful concept, substitution. You can use it in algebra. We could even use it later in calculus. It's very, very handy. It's basically kind of like renaming. So we can say, let's make a new variable. We're going to call it z, which equals y squared. Okay, if z is y squared, then z squared is y to the 4th. Because we can just square both sides. So we could rewrite this as z squared minus 10z plus 9 is 0. Now we have a quadratic in z. We could try this by factoring, and sure enough, it does factor really easily. Look, we have minus 9 times minus 1. So z, we have minus 9 minus 1. And then using the zero factor principle, we could write z minus 9 is 0, but directly we know from factored form that this is just z is 9 is one answer, and z is 1 is one answer. But that's not a solution to the original equation. The original equation doesn't have a z. But now we back substitute, take z back to y to write more equations to find the answer. Now we have two new equations with y. Y squared is 9. So y would be, take the square root of both sides, plus or minus the square root of 9, which is 3, and plus or minus the square root of 1, which is 1. Which gives us four answers. Y is minus 3, minus 1, 1, or 3. Or you can keep it as plus or minus. Either of those is correct. So this equation actually has 4 zeros. Let's solve this equation. Here we have some divisions by the variables, so we're going to have to check for extraneous solutions at the end. Let's just start by saying, or we could check at the end, or we can also keep track as we go, saying let's assume a minus 1 is not 0 and a is not 0, which is also saying that we're assuming a is not equal to 1 if we add 1 to both sides. So at the end, if we get 1 or 0 as an answer, we know that it's not a real answer. So multiplying both sides by a and by a minus 1, we can kind of cross multiply and get this. And so we have a squared is 4a minus 4, and then moving things to the left, a squared minus 4a plus 4 is 0. Not jumping out to me how. Let's see. Oh yes, 2 and 2 might be a solution here. Negative 2 times negative 2 is 4. Minus 2 is minus 4. So negative 2 and negative 2. And it's not an x, where you would have an a as our variable. So a minus 2 squared is 0. And so we only have one answer here, and the answer is a is 2. Is a solution. And that's not 1 or 0, so that's the answer. We could go back and plug that in and see. So you'd have, we plug it back in, we have 2 over 2 minus 1 is 1. Does that equal 4 over 2? Yeah, 4 over 2 is 2, 2 is 2. Let's do another one. So again, we could just start off by saying we're assuming x is not negative 3, so that we don't have a division by 0. But if we do have it, if we get a negative 3 at the end, we'll know that's not an answer to the original. So cross multiplying x squared minus 1, x plus 3 is 8. Okay, this is not quadratic, so hopefully something happens as we multiply this out, or we're going to have trouble solving. X cubed minus x plus 3x squared minus 3 is 8. Okay, so we have x cubed plus 3x squared minus x minus 3 minus 8 is minus 11 is 0. Okay, so oh, of course I made a mistake here. We can't, if we cross multiply, we have x plus 3 on both sides, which is the same as just canceling it out. Okay, so this makes no sense. Let's erase all this stuff. Another way of thinking of that is the numerator, since the denominator is the same, for this to be equal, the numerators have to be equal, right? So x squared minus 1 has to be 8. Okay. So that would mean x squared minus 1 minus 8 is minus 9, has to be 0. This looks, which means, yeah, this is already kind of a perfect, not a perfect square, but we can solve by getting x squared on one side. X squared is 9, taking the square root, plus or minus the square root of 9 is 3. But we're not done. We have to go back and look. And yeah, x minus 3 can't be an answer because it gives a division by 0. So the only answer is x equals 3 as our solution.